Learning target number 6, Unit 5, Inequalities in Two Triangles. An idea of this is when you're looking at a clock and you've got a small hand and a long hand. If we look at the distance between it, if we close it off making a triangle, we can see that this sized hand doesn't change, nor does this one, as it goes around. But the angle in here does change. And that's what we're going to be looking at in this lesson. And that is, when this angle in here changes, what does that do to this side that's opposite? We're actually going to skip through that. In triangles that have two pairs of congruent sides, like a door has the congruent door as well as the congruent part of the wall, there's a relationship between the included angles and the third pair of sides. So when you close the door, the angle between the door and the frame at the hinge gets smaller. The relationship between the measure of the hinge angle and the length of the opposite side is the basis for what we call the SAS Inequality Theorem, also known as the Hinge Theorem. So we're going to add this to your purple sheets. It's called the Hinge Theorem, SAS Inequality Theorem. It says that if two sides of one triangle are congruent to two sides of another, and the included angles are not congruent, notice if they were, we would have congruent triangles by side angle side. But we're saying that these included angles are not congruent, then the longer third side is opposite the larger included angle. So if we have here the measure of angle A is greater than the measure of angle X, then we know the side opposite, BC, has to be greater than the side opposite here, YX, or YZ. Go ahead and pause this movie. Press play when you're finished adding it to your purple sheets. Let's use the Hinge theorem here. Which of the following statements must be true? So we're noticing here with our two triangles that I've got this side congruent to this side, and AK is congruent to OU. The included angle here is 90 degrees. The included angle here is 70 degrees. Pause the movie, choose your choice, press play when you are finished. Since this 90-degree angle is larger than the 70-degree angle, I know that SK has to be greater than UY. So the correct answer is B, because the longer side is opposite the larger angle. And that's based on the Hinge theorem. Let's look at 1A. What inequality relates LN and OQ? Notice I have MN congruent to QP. They're both 7, and these two sides are both congruent by 4. The included angle here is 125 and here is 78. We know that 125 is greater than 78. So what does that tell us about LN compared to QO? Pause the movie, write it down, and then press play when you're finished. Well, we know that the longer side is opposite the larger angle. So we know that LN has to be greater than OQ. And we're going to stop there, 1A. We're going to skip this one. This is based on the Hinge theorem. Scissors also use the Hinge theorem. Their two sides stay congruent, but as this angle changes, the opening size changes as well. Can we state the converse of the Hinge theorem? And then we could write it biconditional. I don't believe you guys know what that is. But the converse of the Hinge theorem we actually call side-side-side inequality, because it says if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is opposite the longer third side. So this is saying if BC is greater than YZ, then I know that this angle, A, is greater than the angle X. So I've got two sides of one congruent to two sides of the other. The third sides are not congruent, but I know that the longer the side will have the larger angle across from it. Pause this movie, add this to your purple sheets, press play when you're finished. We're going to skip the indirect proof. This is an important question. What is the range of possible values for x? We notice in these two triangles, this side's congruent to this side, and by the reflexive property, US is congruent to US. So we can use the Hinge theorem here, looking at these two internal angles. Well, I know 15 is greater than 10, so that tells me that 60 is going to be greater than 5x minus 20. So what I've got to do is I've got to look at two things. I've got to look at the maximum that x can be, as well as the minimum for what x can be. So let's start off looking at an upper limit for x. We know that, based on our Hinge theorem, that 60 has to be greater than 5x minus 20 since 15 is greater than 10. So 60 greater than 5x minus 20, I'm going to solve that. We add 20 to both sides and divide by 5, and we get x is less than 16. So we know that x has to be less than 16. But we also know something else, and that is that this angle cannot be 0, nor could it be negative. So I have what we call a lower limit. For that lower limit, we need to say 5x minus 20 cannot be 0 or less. It can't be less than 0. So we do 5x minus 20 greater than 0. And we solve this guy. Add 20 to both sides, divide by 5. X has to be greater than 4. So the value for x has to meet both of these conditions. Less than 16, greater than 4. And this is how we write it. 4 is less than x is less than 16. Pause the movie, try this problem, press play when you are finished. What is the range of possible values for x in the figure at the right? Here we can see this side is congruent to this side. We know this side, Km, is congruent to NP. And we can see that the sides opposite, 7 and 9, 9 is obviously greater than 7. That tells me 90 is greater than 3x plus 18. So we have an upper limit and we have a lower limit here. We know that with our upper limit that the 3x plus 18 has to be less than 90 since 7, the side opposite, is less than 9, the side opposite the 90. So we'll set that up. 3x plus 18 is less than 90. By adding 18 to both sides, subtracting 18 to both sides, we get 3x less than 72. Divide by 3 gives us x less than 24. The other thing that we need to know is that 3x plus 18 cannot be 0. It cannot be negative. So we set 3x plus 18 greater than 0. This is our lower limit because we know this angle it has to be positive. It cannot be negative. So we subtract 18, divide by 3, and we get that x is greater than negative 6. So our range of possible values for x is that negative 6 is less than x is less than 24. And that's the possible range for x. We're going to skip this proof and that one. And that is the movie for Learning Target 6.